All right, guys. So this example is called the U.S. companies data set. It's one of the examples that got me started in wanting to work in businesses because I saw how people do things and then how I would do things. And you'll see this data set came from Sandy Weisberg again. It's something he had collected with a book he wrote. And he had stored and kept, and I reuse. It's fair use data set. It's just located on his stuff at some point. I'll write it and have it around on my stuff. But the entire idea is this. We've got 79 companies with 6 characteristics on each company. So what we have is we have assets, sales, market value, profits, cash flow, and employees. You can assume all of these are in thousands. So here's what we're looking at. The idea is we want to use PCA to see if there's outliers. So by looking at how to create independent variables, what you get is you get summary statistics, right? You get these summary statistics that if there's an outlier in a summary statistic, you can tell, okay, this thing is way different. So by just taking the PCs, plotting them, and then interpreting what the PCs mean, you see this is an outlier on this metric or in this space. So just to give you some idea, data point 14 is Phillips Petroleum, 22 is Cigna, 28 is the Marine Corps, 38 is GE, 40 is IBM, and 52 is United Technologies. So we're talking about the big boys here. So let's just run principal components, see what we get. Here's the plots. You see what you're looking at in this space as everything relates. You see a lot of 40s and 38s show up. You see a 14, 40, 38, Phillips Petroleum. You see a 68 show up, a 22. So you're starting to see the outliers in this space. But let's see if we adjust for these relationships, what it looks like. So what I'm doing is I'm rounding digits on all of this stuff. The entire idea is this. The entire idea is what we're going to do, and the way we look at things is we're just going to take the principal components of this and see what we get. Take a look at PC1. We scaled and we centered, so everything's good. Take a look at PC1 here. All those numbers look similar to me. So what's that look like to you guys? To me, it looks like the average of these variables scaled, which works well. PC2, well, to me, it looks like assets dominates. PC3, you're kind of looking at employees. If you wanted to come up and say, okay, well, what really comes up with are, employees minus these type of things, you could do that as well. But what it looks like to me is that's employees. You come over here and you start looking, all of a sudden that's employees minus sales. And as you move through, it starts to matter. But let's go down here and look at importance. Take a look at the importance, guys. We're at 98% after 3 principal components. We've reduced the dimension in half. We're at 80% after the first, 83.8, almost 84%. After 2 PCs, we're above 90. So when you're looking at this, the jump you see, really what this says, if you were to use a scree plot, is use 3. Use 3. You could possibly even use 2. But what we can do is now we can come down here and say, okay, PC1, PC2. On PC1, it seems like you have, these are negative values. Negative doesn't really mean anything. Like I said, you could multiply everything by -1. It's not going to change what you see. It's just a large negative sum. We see 40 and 38 have large everything basically, right? So these are the big boys in everything. Asset, sales, market value, profits, cash flow. PC2, basically what we said is that's assets. That's 22 and 28. 22 is Cigna. 28 is the Marine Corps. Makes a lot of sense that Cigna, which is an insurance company, and the Marine Corps have a ton of value, have a ton of assets to them. That makes a lot of sense. They may not be large in everything else relative to 1, but what you're seeing is you're seeing they're large relative to everything else. Now, I've done some things here where I say you can have ID in 4, which means you can go around and click and check these out. You can figure out what observations they are, and then they print out down here after you click 4. All right? So the entire idea is we're going to stick with 2 principal components because this makes a lot of sense. So let's remove 38 and 40. Let's remove 38 and 40 and see what we get. Now, what we're going to do is we're going to start to look at what happens. What changes here? Does anything really change here? Well, look at what we get. Look at what changes if we just remove GE and IBM. If you start looking at this, what you start to see is, okay, again, these are very similar, but assets takes a big down weight here. What it looks like to me is you're looking at the difference between profits plus cash flow and assets and sales. So automatically, principal component 2 went from being just assets to now we have linear combinations of these things, right? Principal component 3 looks like it's assets minus employees. Principal component 4, if I'm looking at this, it's market value minus sales. As you move through it, this is what it starts to look like. So now when we circle back around, we've got 22, 45, 56, and 1. So if we come back up here, are any of those the ones I gave you? 22 still Cigna. So we have a whole new set of outliers to look at. We have a whole new set to go after. If you come over here and you look and you start saying, okay, where's my screen? Where does this change? It looks like 1, 2, and 3 could be useful, 4 not so much. So as you move through it, what you can do is use it to detect outliers in this space. So here's what I want you to do. I want you to go through and I want you to rerun principal components here without 40, 38, 22, and 28. So I want you to remove all 4 of these companies and see what happens if you do principal components on this space. What stands out to you then? If you remove these high everything and then these high asset companies, what else is there? What else are you able to look at? Maybe you want to identify this as well as this, just to see what it is. So change the ID.N to 6, and it should give you here and here as well. So when you're approaching this and when you're doing these type of things, this is what I want you to look at. This is what I want you to see. This is how I want you to approach it, okay? All right, guys, let me know if you have any questions or you need anything.